Okay, in 7.1 we also have these things called a polygon that's inscribed inside of a circle. And you can see what's on the screen here. I've created a circle. The circle happens to have radius 4, which I can actually put in here for us, distance or length. So we can see that the radius is 4 no matter where we are. And that when we place vertices on the circle, right, so the circle has points E, B, C, and D, I think, down here, that they're on the circle and they create a polygon inside. The really interesting part of this is that there is that the radius always stays the same no matter what. But we can create these really interesting shapes with the constraining piece of it being a circle. I've drawn here in the top area a four-sided polygon. Of course, at the bottom I've got this triangle. We could draw any number of different inscribed polygons inscribed in a circle. And the other thing that I'll draw your attention to at the bottom here is, recall that the sum of the angles of an n-sided polygon is n minus 2 times 180. And so I've created these pictures so that the angles are clear up as well inside the polygon. All right, so create some really interesting things. The other thing that I will kind of quickly say is that if I create another circle, let's say it's a radius 3 again, and I can create a regular polygon inside this. So I think if I touch that and touch this, and then I need to tell it how many vertices I want. Let's say I want it to be a 7-sided polygon. And so look at that. There's one way, way, way out here. I'm going to try to grab it, pull it in. Maybe I can't. Oh, I can. There we go. And so we could make that fit really nicely. And now this is not a perfect one. I can create one in another way. But what's really cool in GeoGebra is that we can move these things around a little bit. And what's so interesting here, which we'll study eventually, is that all of these angles here that we can see, up around here, remember that in a regular polygon, all the angles will be equal. And so we've got this really nice symmetric set of triangles, for instance, that are created with radii, of course, because the radii are all the same length. In this particular circle, they're all of 3. So we've got isosceles triangles, which come up over and over again as well. And you'll probably also notice, let's see if I can pen this in a little bit, right around this area, all of these angles are the same, and they are all bisected by the radius. So each of these angles are congruent, which is consistent with the idea of our isosceles triangles. And of course, we know so much about isosceles triangles. And there we go. There's a nice little photo, nice little face. Okay, that's the end of 7.1, polygons inscribed inside of a circle.